In this tutorial, you are going to understand why the coefficient of n squared in the nth term rule of a quadratic sequence is equal to half the second difference of the terms in the sequence. So for example, we have the nth term rule of the quadratic sequence as shown here. So we have the nth term rule as shown here, which is an squared plus bn plus c. So when n equals 1, what we do is substitute 1 into the general quadratic sequence and we get a plus b plus c. When n equals 2, we substitute it and we get 4a plus 2b plus c. When n equals 3, when we substitute that, we get 9a plus 3b. So when we work out the first difference, we get 3a plus b. And we also get 5a plus b. And the second difference really gives us 2a, which is what we are looking for. Now we're going to use this understanding to find the nth term of some quadratic sequences. So I'm going to do one example, after which you're going to do the rest on your own. So here we have a sequence 11, 21, 35, 53, 71, and 101. And you're asked to find the nth term. So as you can see in the top left hand corner here, we have the general quadratic sequence, which is an squared plus bn plus c. So we're going to find the first difference of the sequence here. So the first difference here is 10. Then we have 14, 18, 22, 26. And let us find the second difference now. So that gives us 4. So we get a constant 4. So since we know previously that the second difference is equal to 2a, so we're going to have 2a equals 4. So we need to find a, which implies that a equals 2. And what I've done at the bottom here now, I have the original sequence which was given, and then I'm gonna take the multiples from the original sequence. So we know that a is 2, so we can put in here now 2, so we would have 2n squared, and we're going to take that away now from the original sequence when n is 1. So when n is 1 here, when n is 2, n is 3, n equals 4, n equals 5, and when n equals 6. So let's work this out. When n is 1, we're going to have 1 squared times 2 gives us 2. When n is 2, we're going to have 2 squared, which is 4 times 2, that gives us 8. When n is 3, we're going to have 3 squared times 2, so 3 3s, that's 9 times 2, that's 18. When n is 4, we're going to have 4 4, 16 times 2, that's 32. Then we're going to have 5 squared times 2, that gives us 50. And we're going to have 6 squared, which is 36 times 2, that's 72. And what we do, we take this away now from the original sequence. So 2 from 11 there would give us 9. And then 8 from 21 there gives us 13. And that gives us 17. And that gives us 21. That gives us 25. And that gives us 29. So what we have at the bottom here now is a linear sequence. So we have the first part of our nth term. We know that we have 2a. We have 2n squared, so we can write 2n squared. Now this sequence here now that we have, so this sequence that we have here is a linear sequence at the bottom here, and if you notice, it's going up by 4 every time. So we can find the nth term of this linear sequence. So the nth term of this sequence would be 4n, and it's the 4 times table, so we want to know how much bigger is it, this sequence, and the 4 times table is bigger by 9, by 5. So really the nth term here is going to be 4n plus 5 for this linear sequence. So we can write out the general nth term for the sequence. It's going to be 2n squared plus 4n plus 5. And that's the nth term of the sequence that was given. Now here are some practice questions. Press pause and have a go. So look back at the principles here and use it to find the nth term of the sequences given. So here we have number 1, number 2, number 3, and number 4. You have 4 questions to do. So you're going to use the principles that was outlined previously to find the nth term of these sequences. Thank you for listening, and I hope you do understand how to find the nth term of quadratic sequences.